Welcome to this video lecture on the subject optical and microwave engineering. Now we are going to discuss about reflex klystron. So what is reflex klystron? So it is the microwave oscillator. It is used to generate the microwave signals. So it is basically a type of vacuum tube used in electronics for generating or amplifying the microwave signals. So between the range of 1 GHz to 40 GHz. So the basic principle behind the klystron is the velocity modulation of an electron beam passing through a resonant cavity. So here the name reflex comes from the fact that the portion of energy from the output signal is reflected back to the tube and it is used to modulate the electron beam. So reflex klystron is used in micro ovens, radar systems, communication systems and particle accelerators. So it is basically a microwave oscillator. So here the sum of the characteristics. So here the resonant cavity we are using, it is made up of two cylindrical cavities. So here the cavities are separated by a small gap known as the drift space. And the electron beam, the electron gun is used to produce a narrow high velocity electron beam towards the resonant cavity. So the electrons are focused by magnetic field, so which are made to pass through the drift space. And the bunching, so as the electrons pass through the drift space, they are affected by the alternating electric field produced by the resonant cavity. So this causes the electrons to bunch together, forming the group of bunches. So here we can use the klystron as the amplifier also, where the bunches of electrons that pass through the cavity interact with the electric field. So the field can be amplified. So here the amplified field interacts with the next bunch of electrons, so resulting in further amplification. So and for oscillation, we use the interaction between the electron beam and the resonant cavity can cause the cavity to oscillate at a frequency determined by the cavity resonator. So here we can see the working principle of reflex klystron. So in this diagram, we have a structure of reflex klystron where we are using the electron gun. So here the electron beam is emitted from this electron gun and then we have a repeller at the end. So repeller used to maintain a negative potential to reflect the electrons within the cavity resonator. Here cavity resonator is given as the rectangular cavity resonator. So inside this tube, the electron is emitted and it is traveled through the drift space and then it is repelled back by the repeller negative potential and it is interacting with the cavity field. So this interaction of electron beam and resonant cavity generates or amplify the microwave signals where the electron energy of the electron beam is transferred to the field present inside the cavity resonator. So it produces sustained oscillation to produce the microwave signal. So the electron beam formation. The electron beam is produced by an electron gun and it is directed towards the cavity. And next step is the bunching of electrons. So where it produces the bunching of electrons or velocity modulation of the electron beam in between the drift space. And the repeller distance and the repeller voltage can be adjusted to receive all the electrons at the same time on the positive peak of the cavity RF field. So this velocity modulated electrons are bunched together and lost their kinetic energy when they encounter a positive peak of the RF field. So here, like this micro oscillation is started. So the interaction between the electron beam and resonant cavity can cause the cavity oscillate at a particular frequency. So this produces the microwave signal. The portion of energy from the output signal is reflected back to the tube and is used to modulate the electron beam. So this results in the higher efficiency. So the interaction, how it happens. When the bunches of electron pass through the resonant cavity, they interact with the alternating electric field of the cavity. So this interaction causes the electrons to gain energy, which results in the increase in velocity of electrons. So this is known as the velocity modulation. So some advantages of this reflex klystron are high frequency stability and high power output, compact size and low noise and long lifespan. So overall the reflex klystron has high frequency stability, high power output, low noise and long lifespan. So it is a reliable option for wide range of microwave applications. And some disadvantages are they require high voltage power supply to operate, so will be expensive and they pose a safety risk. Unlimited frequency range, limited power control and the sensitivity to temperature changes and complexity. So some of the applications of reflex klystron are radar receivers, local oscillators at microwave receivers and portable microwave links, pump oscillator and parametric amplifiers. And some of the performance characteristics are applied to reflex klystron. And we are taking a small assessment. The klystron tube is used in klystron amplifier belongs to. So here the four types of fields are linear beam, crossed field, parallel field and last option is none of the mentioned. So which beam is used as the klystron amplifier? The answer is linear beam tube because the electric field and magnetic field are parallel to each other in the klystron tube. And which is the single cavity klystron tube, which operates as an oscillator by using the reflector electrode after the cavity. So the answer is reflex klystron. So what we discussed in this lecture is single cavity klystron. Thanks for listening this video lecture.